All right. Hello, everyone. Thank you for watching my video, clicking my video. My name is Glenn. In this presentation, I'll be walking you through the Secure Shell Protocol, commonly known as SSH. We'll explore what it is and how it works, its default configurations, and how it's used in our lab environments for securing remote access and system administration. So let's dive right in. So, as I said, SSH is a secure shell protocol. It's used for encrypted remote access and administration. The default port it runs on is on port 22. SSH is a cryptographic network protocol that allows secure communications over an unsecured network. It's primarily used for logging into remote machines and executing commands, but it can also be used for tunneling, port forwarding, and trans- um, transferring files securely. SSH replaces older and insecure protocols like Telnet or rlogin. So next we'll go over the installation or installing OpenSSH on Linux. The command for that will be sudo apt update with the two ampersand sudo apt install ssh dash server dash y. So by default, SSH operates on the TCP port number 22. The key components of an SSH connection are the SSH client and the SSH server. The client initiates a connection, and then the server handles authentication and access control. The service on the service on Linux systems is usually provided by SSH HD or the SSH daemon. So for our lab, I'll go over the configuration or the installation process and configuration process as well. First, we have to start by enabling our SSH. So that would look like sudo systemctl start SSH. And then to enable the sudo systemctl enable SSH. And then to verify the status of SSH, we'll do sudo systemctl status SSH. So how next I'll go over how SSH works. When a client connection to the server, when a client connects to the server, uh, SSH uses a process called public key cryptography. The server presents its public key, and then the client can verify it using a known host file. Um, the connection is then encrypted using the symmetric encryption. It's a symmetric encryption to symmetric encryption which is negotiated during the key exchange. This ensures that data cannot be intercepted or read in transit. So for our lab, we will also have to verify or check that, verify to check to see if our installation process or our installation for OpenSSH was successful. So we can check if it's listening on the correct port. As I said, the port number for SSH again is port number 22. So we'll use the ss command or sudo ss and then grep SSH to check if it's listening. And if it's successfully configured, we should have a SSH port open or SSH listening. So we'll talk about the authentication methods for SSH. So there are two main authentication methods used with SSH. The first one is password based, where user login is used. It's using use a username and a password. And then the second is key based, where users authenticate using a private key that matches a public key stored on the server. Key based authentications is much more secure and is strongly recommended, especially in production environment. I don't know about a lab environment, but more important for or strongly recommended for a production environment. We can also use it for a lab environment as well. So the basic configurations for SSH will be to edit the SSH configuration file, which is in sudo with the text file nano, and then etc sshhd underscore config, where we'll be able to make key changes like the password authentication, the port number, where we could change the port number instead of just having it as 22, we can make it 222, 2222, or we can do permit root login as well. So for SSH configuration file, the SSH settings are defined in the sshhd underscore config file, usually, which is usually located at the, as I said again, etc /ssh/sshhd underscore config. From this file, we can configure options like our port number, or which port SSH is listening on, whether root login is allowed, and what authentication methods are permitted. We can then restart in. We will then restart the service SSH service after we apply any changes. Next, for the firewall configuration for SSH, since in this lab we are using IP tables, so we only use IP tables. We can get rid of the firewall D. So for this lab, we're only using IP tables. So to secure SSH, we can apply the following hardening steps. First, as I went from the previous slide, is we could change the default port number from 22 to 2222, and then we can also disable root login by setting the permit root login to on, and this can all be done in the configuration file or the nano file. In my case, I prefer the nano file. I know there are other options, but I prefer the nano file. Next, we could also use key based authentications only, and then we can also limit login attempts using tools like a fail to ban. These practices help protect against brute force attacks and unauthorized access attempts. So for our hardening SSH authentications, we could choose just multiple options. We can generate a SSH key pair with the command SSH keygen -t rsa -b 4096. We could also copy the public key to the server. So we could do SSH copy ID user at our server IP. And then we can also disable password authentications in the SSH HD underscore config file. So SSH offers a major improvement over legacy protocols like Telnet, which transmit data including passwords in plain text. In contrast, SSH encrypts the entire session, protecting against eavesdropping and man-in-the-middle attacks. So on the for our okay, I'll go over some common SSH commands. For here, so a few essential SSH commands can be the SSH keygen, like I said, to generate a key pair. We could also do the SSH copy ID to install your public key on a remote server. Since we can use this we can use these options, or we could use these often in our labs for automation and server file transfer as well. We could do the SSH username and then add our IP. That's to initiate the connection to our server. We could do the SCP file at our FCP file, then user at our host, and then with the path as well to securely copy files to our server as well. And then we can do for the configuration or our hardening, we could do the as we went over the okay, we can also configure SSH jail, which is the in our will be in our fail to ban, which is another thing we have to download for our hardening. And then we can do in SSH HD, we can enable port, change our port. That's where we can make our configurations. We can also set a ban time as well. And then of course we then go through and restart our fail to ban as well. So here's what I have for hardening SSH. When we're limiting user access, we can restrict SSH access to specific users as well. This is for more hardening. So we can also allow users, allow usernames, allows users username restrict the, and restart the SSH. And then we could do sudo restart SSH. So we could go in our config file and then allow usernames as well. So for next, we just verify that our service is running properly on the correct port, which in this case for our lab is port 22. So here we'll run a nmap scan towards our server. So the command for the scan will look like nmap-p-22, where we can specify the port we're scanning for, and then our server IP. In case where we don't want to specify, just do an overall scan. We could just do a dash and get rid of the 22, which would just do a kind of a scan, all around scan towards our server. So for troubleshooting SSH as well, we could also do, sometimes it won't connect. So we could maybe have incorrect IP or incorrect port number, or maybe SSH is not running, or the firewall might be blocking port 22, or this could be a plethora of things. There's just a few I came up with, or this could be a permissions to open a private key file. SSH is strict about this. In our labs, checking these things can quickly help us get back up and running in case we do have any issues. So to wrap up this for SSH, SSH is a fundamental protocol in cybersecurity and system administration. It provides a secure way to manage system remotely, and is something every security professional needs to understand deeply. In our course labs, using SSH and securing SSH has helped us simulate real-world scenarios and build our technical skills. Thank you for watching my video.